Good morning, everyone. My name's Aman and welcome to this GCSE Chemistry session. Today we'll be looking at the electrolysis of aluminium and brine. So if you were here last Friday, you'll remember that we did an introduction to electrolysis, specifically looking at molten and aqueous solutions and what happens to the products of those when we carry out electrolysis. Today we'll be looking at those in a bit more detail with two specific examples. We'll also be looking at half equations, which I know we didn't manage to get onto last week. As usual, if you have any questions at all, please pop them into the chat box or the Q&A function, and I will pick them up as we're going along. And as usual, this is a 1 hour session, so starting at 9:45 and finishing at 10:45. If you haven't met me before, my name's Aman and I study medicine at King's College London. I've done plenty of lessons with MyTutor and I've run all the online school chemistry sessions that have been carried out. Okay, so let's get started. So the learning objectives today are to be able to write half equations for what occurs at each electrode, and this is higher tier, so we were supposed to cover this on Friday last week, but we didn't get time to do that, so we'll be looking at that today. We need to know the process for the extraction and electrolysis of aluminium oxide. Again, that's molten electrolysis, so we'll be looking at a specific example of what happens when we do that electrolysis, and then one with an aqueous solution will be with brine. And then finally, we'll be doing lots of exam questions. So there won't be a quiz today just because I want to focus on exam questions, but we'll resume doing a quiz tomorrow. Okay, so before we go into half equations then, a quick recap of what we covered last week. Does anyone remember what the positive electrode is known as? So when we carry out electrolysis, there are two electrodes in there. One is a positive electrode and one is a negative electrode. And that positive electrode has a name. Does anyone remember? Good, it's the anode, and the way that I kind of helped you to remember it last week was to say that anions are negative ions, such as the chlorine ion is a negative ion, and we call that anion or an anion, and it is attracted to the anode. So negative is attracted to positive, so that's how I remember that the anode is positive. Great, why does electrolysis require molten or aqueous electrolytes? Why do we need molten or aqueous electrolytes? Why can't we just carry it out on a solid? Any ideas? I've heard one answer so far. Any other answers? Why does electrolysis require molten or aqueous electrolytes? Excellent. So it's about the ions being able to move. So it's not about electrons, because remember, when we carry out electrolysis, it's always on ionic compounds. So it's really important that the ions are able to move. So hopefully you remember that we looked at ionic compounds a couple of weeks ago and they form a giant lattice. And that lattice structure is very strong. The ions can't move because of the strong electrostatic attractive forces between the ions. So what's really important then is that we need to either melt that ionic compound or dissolve it in a solution to allow those ions to freely move. And the other thing is that when we melt it or allow it to dissolve in a solution, an electric current can pass through it. Excellent. What is produced at the electrodes in the electrolysis of molten magnesium bromide? So the key word there is molten. So molten magnesium bromide, what's produced at the cathode and what's produced at the anode? Good. I've had a couple of correct answers so far. I'll just wait another couple of seconds for anyone else to answer if they want to. So remember, molten magnesium bromide. I think the way I described it last week was to say that the molten's the easier one to remember, just because usually it's what's in the question that's produced. Good. So at the cathode, we will produce magnesium, either as a solid or as a sludge. And the reason for that is that magnesium forms Mg2+ ions. It will then be attracted to the negative electrode, which is the cathode. So will be produced at the cathode. And the bromide forms Br- ions and will be attracted to the positive electrode, which is the anode. So yes, magnesium at the cathode and bromine at the anode. And usually bromine will be formed as a gas. But again, you don't necessarily need to know the state. Usually they just ask for the products in exam questions. Okay, what's produced at the electrodes in the electrolysis of aqueous magnesium bromide? So this time aqueous. There are a couple of rules we have to remember when we do aqueous electrolysis. So this one can be slightly more tricky. So as a reminder, there are 4 possible products that could be produced. And the reason for that is that aqueous solutions mean that the magnesium bromide is dissolved in water. So that means in the water, there are ions, the hydrogen ions and the hydroxide ions. So that means that at the cathode, we could either produce hydrogen or magnesium. At the anode, we could either produce oxygen or bromine. And there are rules to remembering which ones are produced. Good, okay, so I'm pretty sure everyone's given me the right answer there. So at the cathode, we will form hydrogen, and the reason for that is that hydrogen is less reactive than magnesium. And the examples that I gave last week were looking at the reactivity series, and you'll remember that I said that if something is more reactive than hydrogen, which magnesium is, that means hydrogen will be produced. And the reason for that is that at each electrode, what's occurring is that the hydrogen or the magnesium is gaining electrons to essentially become an atom or an element. So the hydrogen ions will go to the cathode, the magnesium ions will go to the cathode, but because the magnesium is so reactive, it doesn't want to gain those electrons. It likes having one less or two less electrons, whereas hydrogen isn't that reactive, so it's quite happy to gain those electrons. So it's about how likely they are to gain electrons, and when they're more reactive than hydrogen, they are less likely to want to gain electrons, whereas when they're less reactive than hydrogen, that means they are more likely to want to gain those electrons. With the anode, everyone's right, it's bromine. So there are a few rules with regards to whether bromine is produced. The first thing is whether it's concentrated. So in this question, it didn't say whether it's concentrated or dilute, so you can assume it's concentrated. And that basically means then that bromine is produced. And remember last week, I said the only thing that can be produced at the anode is either oxygen or bromine. And the reason hydroxide ions aren't produced is because when hydroxide loses some electrons, there are two products formed, water and oxygen. The water will just dissolve into the solution that's already there. The oxygen is what is produced primarily at the anode. So to those that are asking me about hydroxide ions, that's the reason. The first answer is anode. That's the first answer is anode. The second answer there was because the ions are able to move when we heat the ionic compound or when we dissolve it in a solution. Magnesium and bromine at the cathode and anode respectively, and in this question it's hydrogen and bromine at the cathode and anode respectively. Great, well done everyone. Any questions on that before we move on to ionic half equations? Okay. As usual, if you have any questions, please just pop them into the chat box or the Q&A. Okay, so this is what we didn't manage to cover last week. And what I want to talk about today is kind of how we make these half equations. It is a higher tier topic, so it's not a core topic. So first of all then, let's look at the cathode and what happens at the cathode. So we know that the ions that are attracted to the cathode are positively charged ions. So things like magnesium, things like calcium, hydrogen, potassium, all of these ions, the metal ions usually will form positive ions like so. And they are attracted to the cathode. So the purpose of ionic half equations is to write down what's happening at the electrode. So if we start with hydrogen, we know that hydrogen will go to the cathode and essentially it's going to become a gas. It's going to become H2 gas. So what's happened is it's going to go from being positively charged to being neutral. And so to become neutral, it needs to gain some electrons because at the moment it's lost some electrons. So it needs to regain those electrons. So what happens at the cathode, as shown here, is that it gains 2 electrons to become hydrogen gas. So the half equation is H plus E minus to become H2. And then we just balance that. Now, because 2 hydrogens are produced, because it's a gas, it goes around in a pair, that means we need 2 hydrogen ions. And if we have 2 hydrogen ions, we need to gain 2 electrons. So the balanced half equation for hydrogen, one of the most important half equations we need to know, is on the screen now. The other ones we need to be able to do are the metals. They are a little bit easier because they don't usually require balancing. So for example, if we look at aluminium, aluminium forms a 3+ ion, which again, you look at the periodic table, it's in group 3, that means it forms a 3+ ion. That means to become neutral, it needs to gain 3 electrons. So we add 3 electrons on, and then it will just become aluminium metal, like so. The other example on here is lead. Lead forms a 2+ ion. That means it needs to gain 2 electrons to become lead metal, which is neutral. Any questions on those? So that's what happens at the cathode. So cathode means negatively charged electrode. It's just a fancy term for negatively charged electrode. Higher tier, so most exam boards split their exams into foundation, core and higher. If you're doing the foundation tier exam, you will do a lot of core and a lot of the kind of more difficult things will be at the end of the paper, but they won't reach into levels 7, 8 or 9. So it goes up to level 6, I think is the highest. And with the higher tier, you will reach all the way up to level 9 questions. So they will get progressively harder as the paper goes on. Okay, so there's no questions there on what happens at the cathode. So now let's think about the anode. So at the anode, if we take bromine, for example, we know bromide ions are Br minus. So Br minus. And that means to become neutral, they actually need to lose an electron, because at the moment they've got 1 more electron than proton. That's why they're negatively charged. So to lose that electron, they go to the anode and essentially they lose it. So, but what we need to remember is we need to balance that equation. So if we have Br minus, they lose that electron, so they minus off an electron. It's then going to become Br2. And the reason for that is that bromine and all the halogens go around as pairs. So that's important to remember. So we just need to balance it. So that means we need 2 bromide ions and 2 electrons there, because every bromide ion will lose 1 electron. Now, with the anode, there are 2 ways that these half equations can be written, and it's up to you how you want to write it. So I always prefer to write it like this, where you have the bromide ions losing 2 electrons. But the other way you can write it is to say that 2 Br minus becomes Br2 plus 2 electrons. And what that is saying is that when the bromide ions go to the anode, they become bromide gas or bromine gas, and 2 electrons are also given off. So essentially we've moved this to the other side. And remember, when we move something to the other side, we have to make it neutral on the side that it's been lost from. So essentially we add it to this side to make it 0, and we add it to the right-hand side. So that's just, remember in maths, when we're balancing, when we're rearranging equations, we're just moving it to the right-hand side. So as I said, I prefer this, but examiners will also accept the second one. It's up to you, however you prefer to do it. Okay, the other example on the screen is probably the hardest one we need to remember, and that is what happens to the hydroxide ions. So remember, in most of electrolysis of aqueous solutions, we either produce the halide or we produce oxygen. So if we look at this hydroxide ion and what's happening here, so first of all, we have our hydroxide ions, OH minus. They're going to produce water and oxygen, which I told you about earlier, and they're going to lose some electrons. So at the moment, if we've got 1 hydroxide ion, it's going to lose 1 electron to become hydroxide neutral. And that actually just produces water and oxygen. So it's a bit of an anomaly in that we've got different products. But when we balance this equation, we know that oxygen goes around as a gas and water is H2O. So first of all, we've got an uneven number of oxygens there, so we need to make that even. So we need to put a 2 here. And now we have 4 oxygens and 4 hydrogens. And so what that means is the hydroxide needs to become 4. And then if we have a look at our electrons, because we have 4 hydroxide ions and each one loses 1 electron, that means we need 4 electrons. So the fully balanced equation for the hydroxide ions is in the pink now. So 4 hydroxide loses 4 electrons to become 2 waters and 1 oxygen. And as I said, you can write that like that, which is the way that I prefer. If not, you can write it like this. So you have 4 OH minus goes to water plus oxygen plus 4E minus. And what's really important there is that you've moved the electrons onto the right-hand side and they've become positive, because if you think about it, that the hydroxide ions go to the anode, and what's being produced at the anode then is your water, your oxygen, and 4 electrons are being released from those hydroxide ions. So you can think about it like that. We won't lose marks, will we, if we use the first one? No, you will not lose marks. Hydrogen does go around as a pair. Yep, great. Someone's asking, is anyone else's screen freezing a bit? I don't think we're having any technical difficulties at the moment, so if anyone else is having that problem, please let me know. Which year is this taught in and what grade would this be? So this is a higher tier topic. Half equations, I believe, are grade 7 to 8. When would you need to reduce hydroxide if it's not a halide? Do you mean produce hydroxide? I'm not sure what you mean there. And so the other thing we need to just discuss with this half equations is what's occurring at each electrode. So if at the cathode we're gaining electrons, what do you think is the overall process that's occurring? What process is occurring at the cathode if we're gaining electrons? Okay, you guys are thinking on the right lines. I've got a few. Okay, so at the moment, I've got a couple of answers for oxidation and a couple of answers for reduction. You're all on the right lines. It's one of those. So remember the mnemonic oil rig. What do we think then is happening? Oil rig. Good, it's reduction. So oil rig is oxidation is loss, reduction is gain. So at the cathode, we've gained 2 electrons. That means at the cathode, reduction is taking place. At the anode, we're losing electrons, and therefore at the anode, oxidation takes place. And I've seen exam questions ask that, so just to kind of ask you what's happening at each electrode, is it oxidation or reduction? I fully recommend just using the mnemonic to help you. Great, okay, so let's do 2 examples. So write a balanced half equation for iodide ions. So I'll give you a minute or two to think about that. So iodide ions. So remember, they are non-metals. Where do they go? What's going to happen? Are they going to gain or lose electrons? And what's going to be produced? And then try and balance it. So iodide ions, they're a halogen, so they form I- ions. Got I- ions. Someone's asking me, I haven't seen oil rig before, but it seems really good. When you were doing your exams, did mnemonics help you a lot? Yeah, so there are certain mnemonics that did help me. So for example, the reactivity series, oil rig was a really useful one, especially in A-level as well. The other mnemonics that can be helpful are things like remembering kind of about protons, electrons and neutrons. But I sometimes find that when you've been studying certain topics for a long period of time, you tend to just remember them. So you won't need mnemonics. In physics, I used to use a lot of mnemonics as well. Good, okay, so 2I- plus 2E minus, we've got there, goes to I2, so almost. So we've got, first of all, our I minus are going to need to lose some electrons because they are negatively charged. So if I put minus E minus first, and then we're going to produce I2, which is excellent, it's a halogen, it goes around in a pair. Then we just need to balance it, the 2E minus minus 2E minus, sorry, 2I minus minus 2E minus, like that. And just to say, we write electrons as E minus, that's just the conventional way to write them. Great, so you could have also written that as 2E minus goes to I2 plus 2E minus. So just remember it's a plus, not a negative if you're moving it over to the other side. Great, well done everyone. The second one then, write a balanced half equation for calcium ions. So calcium are in group 2. Calcium are in group 2. So that should help you work out the charge on the calcium ion. Okay, good. We've had a couple of examples. So someone has tried to balance it by putting a 2 in front of everything. Remember, if there's a 2 in front of everything, we don't need it. That means we can just remove it. So it's kind of almost like a ratio. If we've got 2's in front of everything, we can simplify that ratio. Good, okay. So calcium forms a Ca2 plus ion. First of all, it's positively charged. So to make it neutral, we need to gain some electrons. We're going to add some electrons on. And because it's a 2 plus ion, that means we need to gain 2 electrons. And then because it's a metal, we just form calcium like that. So we don't need to balance that at all, really. So yeah, well done everyone. That gave me the answer to that, excellent. So yeah, you don't need to balance it. It's all kind of already balanced for you. Good. Okay. Any questions on that then? So that's writing half equations. And as I said, this was kind of what we were supposed to cover last Friday. Do you need to know the periodic table off by heart, or will you be given the table in the exam? You'll definitely be given the table in the exam. It's always an insert. When would hydroxide go to the anode? So that's a really good question. Just hang on to that question for a bit. When we come on to the electrolysis of brine, which we will in about 10 or so minutes, I will go over again when hydroxide is produced at the anode. All right, so just hang on to that question. How did I remember the formulae? What are you talking about, the formulae for the ionic compounds? Sorry, the ions, so which groups they're in. If you're talking about that, the reason I remember some of where the ions are is because a lot of the common metals and non-metals, when you've been looking at the periodic table for a lot of years, you just kind of remember where they are. So, and it also becomes kind of ingrained. So I know calcium will always form a 2+ ion and it's in group 2, but that you don't need to know that. You will get the periodic table and you can just look at which group it's in. Okay, so first bit of content for today then, we're looking at aluminium and extracting aluminium. So aluminium is the most abundant metal in the Earth's crust. So what that means is that when we extract it from the Earth's crust, abundant means that it's one of the most common metals that we find. What are some of the uses of aluminium? Can anyone give me a couple of uses? What do we use aluminium for? We think about in the household. Good, yep, cans, foils, aircraft, sinks, yep, excellent examples, really good. So basically aluminium is used in a lot of things. Tin foil, great. So the reason all the exam boards want you to know about the extraction of aluminium is because it is so common and also because it's done using electrolysis, so it fits in nicely with this topic. So aluminium is extracted from its ore, bauxite. So what that means is that in the Earth's crust, when we're looking for aluminium, we would find it as an ore called bauxite, so almost like a rock. And the ore is mined by open cast mining. So that means digging it directly from the surface. So we dig out the bauxite from the surface of the Earth's crust. But the problem with that is that it's mixed in with lots of impurities. And the impurities, one of the main ones is iron that it has in there. Just a question, but do you think it's best to memorize the state symbols of the reactivity series? So remember, with the reactivity series and state symbols, it depends where you're doing the reaction. So for example, hydrogen at room temperature will be a gas. But for example, in hydrochloric acid, it's not a gas, it's an aqueous ion. So it would be aqueous. So I wouldn't recommend learning state symbols. There's not a quiz today, but there will be one tomorrow. The reason there's not one today is because I need to focus on exam questions, because this is our last session on electrolysis and we didn't do any last Friday. Okay, so as I said, when we take out the bauxite from the earth, we have these impurities mixed in with it, and these impurities tend to be iron. So what we tend to do to get rid of those impurities is to do something called the Bayer process. You don't need to know about this, but if you're interested, there is a process called the Bayer process. It used to be on the GCSE exam boards, it's not anymore. The Bayer process, and essentially that is dissolving that bauxite ore in sodium hydroxide. And when we dissolve it in sodium hydroxide, most of the oxides, so the aluminium oxide in that ore, will dissolve, but the iron oxides will not dissolve. And so what that means then is it will be left as a solid and we can filter it off. So we can do filtration to remove those impurities. So we'll be left with aluminium oxide, which is what we want. So just a recap of that, we get the bauxite from the Earth's crust. It's got lots of impurities in it. So we carry out the Bayer process. And what the Bayer process does is dissolves the bauxite in sodium hydroxide. That then will dissolve all the aluminium oxide, which is what we want. And the iron oxides, which are impurities, will not dissolve, and so we can filter those off. So as I said then, this is the purification, and a white powder from which aluminium can be extracted is what is produced. So the purification process is the Bayer process. Someone's asking, is this AQA? No, so I believe the extraction of aluminium is in Edexcel, it's in AQA and OCR. Okay, so what we need to know specifically then is about the electrolysis of aluminium. So first of all, aluminium oxide has a very high melting point. So remember I said that we have our bauxite, that's got lots of impurities in it. So we go through the Bayer process, and then after the Bayer process, we produce aluminium oxide. And it's the aluminium oxide that we do electrolysis on. But the problem is that remember when we do electrolysis, we can either make it molten or we can make it aqueous. Now, because we want, when we do aluminium oxide, because we want aluminium to be produced, we can't dissolve it in solution. Because if we dissolve it in solution, remember what happens is that hydrogen will be produced at the cathode. So to ensure that aluminium is produced at the cathode, we have to make it molten. And so essentially we have to heat it up. But the problem with heating aluminium oxide is there's got a very high melting point of greater than 2000 degrees. And so what's the problem with a high melting point? What does that mean for industry if it's got a really high melting point to make it molten? Someone's asking, why are there lots of exam boards? I don't actually know the answer to that question. I think there's just lots of different exam boards for schools to choose from, depending on which content they want to teach. Good, so a lot of energy is expensive. It's costly. Yeah, it's global warming as well, because obviously energy comes from burning fossil fuels, so it releases carbon dioxide. Great. All really good examples. So the reason we don't like melting aluminium oxide is because it's got such a high melting point. So what we do then is we dissolve it in something called cryolite. And cryolite is an aluminium compound, but the benefit of cryolite is that it has a lower melting point than aluminium oxide. Its melting point is about 850 degrees, which is still high, but it's much lower than the 2000 degrees that was there before to melt aluminium oxide. So we basically dissolve it in cryolite, but when we dissolve it in cryolite, because it contains aluminium compounds, it's not a solution, it's essentially making it molten, because we heat up the cryolite and make the aluminium oxide molten. And so that energy keeps that electrolyte molten. So the important part from this slide is that aluminium oxide has a really high melting point. So to get around that, we dissolve it in cryolite, but this is not an aqueous solution, this is molten. So we just heat it up and it's got a lower energy when we heat that up. And so that saves fossil fuels from being burnt, and also it saves costs. So what's happening then when we do electrolysis of aluminium oxide? So first of all, we can see here the solution of aluminium oxide in molten cryolite. We've got our cathode, which is our negative electrode, and our anodes. They're made of carbon, which remember are inert, which means they're unreactive. And the reason they're unreactive is so they don't react with the aluminium oxide, because we don't want them to. But there is something special about the electrolysis of aluminium oxide, which we'll go into in just a second. So first of all then, I've already told you what's produced at the cathode. And I've said that the reason we don't do aqueous with aluminium oxide is because we want aluminium to be produced. So I've told you aluminium will be produced at the cathode. What will be produced at the anode? It's molten aluminium oxide. What will be produced at the anode? So cathode produces aluminium, which is Al3+ for the person that's asking, and then anode will produce what? Good, oxygen, excellent. And the reason it's oxygen is because it's aluminium oxide. The person's asking me for the, that's aluminium oxide as a compound. So yep, so oxygen will be produced. I'm just going to put this as aluminium because it wouldn't have a charge there. Okay, great. So let's write the half equations for that then. So at the cathode we have aluminium. So any ideas? What's the half equation for aluminium? I'm not an invigilator and I'm not an examiner, no. I just have a lot of experience with exam questions. Good, excellent. So we've had a few answers for the half equation for aluminium. It forms an Al3+ ion. That means it needs to gain 3 electrons to become neutral. So it gains those 3 electrons to become aluminium. Excellent. So that's what we want as one of our products because it's aluminium that we do the electrolysis for. And then at the anode, what happens there? So we've got oxygen. I'll tell you, it forms O2-. That's the charge on oxygen, O2-. It's in group 6. What do you think is the half equation? Half equation for oxygen. So O2- is its ionic charge. Good, yep. So it will lose electrons. So O2-, oh, that was not written correctly. So O2- will then lose electrons to become oxygen, which remember is a pair. So the problem with that is because we have 2 oxygens there, we need to make this 2, which means then that we need 4 electrons. So that's the balanced equation for oxygen. Any questions about that? Because that one's also a little bit tricky. Someone's asking what's a half equation. So remember, it's the equation that's occurring at each electrode, either by gaining or losing electrons. Good, so people that wrote it the other way round, you can also write it as 2O2 minus goes to oxygen plus 4E minus. So you can write it either way. Good, okay. Yeah, so just remember to balance it. So the people that forgot the 4E minus, just remember we need to balance it. Great, well done everyone. So there's one kind of final point we need to know about doing the electrolysis of aluminium oxide, and that is to do with the carbon electrodes. So at the anodes, we know oxygen is produced and the electrode is formed from carbon. So any ideas what the problem is with having an oxygen produced on a carbon electrode? Any ideas? Okay, I've had one correct answer. Yeah, brilliant. Yes, excellent. Okay, so everyone's giving me the correct answer there. So what's happening is that at the anode, because oxygen is being produced, it reacts with the carbon electrode and it produces carbon dioxide. And the problem with it producing carbon dioxide is that it eventually wears away this anode or burns it down. And so that means that these electrodes have to be replaced really frequently. And so that adds to the cost of the process. The reason we don't use something like platinum is because platinum can be expensive, whereas carbon electrodes are really cheap. So often industrialists prefer replacing those electrodes frequently rather than using more expensive electrodes. So as a summary then of what we've just covered, aluminium is formed at the cathode. That's its half equation there. So aluminium 3 plus 3 electrons will become aluminium. And someone asked me, is it a liquid or a solid? It tends to form kind of a molten liquid, sort of sludgy type liquid. Oxygen is formed at the anode, and that's its half equation there. But remember, you can write it the other way around. So the other way around would just be 2O2 minus goes to oxygen plus 4E minus. So either way is fine. The carbon electrodes react with oxygen gas to produce carbon dioxide. So that's what this equation here is. So we've got there oxygen gas reacting with carbon to produce carbon dioxide. And then finally, the carbon electrodes must be replaced frequently, adding to the cost of producing aluminium. And that's because that carbon dioxide burns away those electrons. And so it is harmful for the environment, yes, but we need aluminium. And so this is kind of one of the only ways we can produce aluminium. So that's why we do the electrolysis process. And we try and reduce costs and energy as much as possible. That's why we dissolve it in cryolite. Okay, brilliant. So that's all about the electrolysis and extraction of aluminium. The final thing we need to cover then is the electrolysis of brine. And I know this is a really kind of key topic in exam questions. They love asking about brine. So the first thing we need to know is what brine is. Brine is sodium chloride, and specifically it's a solution. So that means it's dissolved in some kind of solvent. And this is our reactivity series on the screen here. So you remember we saw that last week. Does anyone have any mnemonics for the reactivity series? Any mnemonics that people have for the reactivity series? While I'm waiting on that, we'll talk about brine. So brine is a concentrated sodium chloride solution. Keyword concentrated there, concentrated. We'll come back to that in a second. It's sodium chloride, so remember salt, but it's in a solution, so we call it brine. Okay, what will be produced at the cathode? It's aqueous. What will be produced at the cathode? Any ideas? So remember, there are two things that could be produced, either hydrogen or sodium. So we use the reactivity series. Brine is made up of sodium chloride, NaCl, sodium chloride. It's just sodium chloride dissolved in water. Good, hydrogen will be produced. And the reason hydrogen is produced is because hydrogen, or sodium, sorry, is more reactive than hydrogen. And remember, the rule is that if something is more reactive than hydrogen, hydrogen will be produced. If something is less reactive than hydrogen, so copper, silver, or gold, they will be produced. But because sodium is more reactive than hydrogen, that means it is less likely to want to gain an electron. So remember, it forms Na+, it has to gain that electron to become sodium. It is less likely to want to do that, whereas hydrogen is more likely to want to do that. So hydrogen undergoes the process of forming hydrogen gas, like so. Okay, what we produced at the anode? It's not like a displacement reaction, because in displacement reactions, remember, the more reactive metal will displace the less reactive metal. So it's almost the opposite. Sodium chloride, is sodium chloride another name for brine? Not quite, because sodium chloride dissolved in solution is brine, whereas sodium chloride solid is salt. Good, chlorine will be produced. And the reason for that is it's concentrated, so we form chlorine at the anode. And remember then that chlorine forms Cl minus ions. So does anyone want to write the half equation for chlorine for me? Because I don't think we've done that one yet. So the half equation for chlorine. Okay, so we've had a few mnemonics. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. Yeah, that's a really cool one. I like that one. So I'll write that out for people that haven't seen it. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. Excellent. Yep, I really like that one. So that's one mnemonic. I think we had one more as well, so I'll just get that one up. Okay, so the other one we had was, please send lions, cats, monkeys, and cute zebras into hot countries somewhere good. Yeah, clearly there's an animal theme going on, which is great. Someone said, please stop calling me a cute zebra. I like happily calling myself smart. Someone's got panda, snake, lion, chameleon, monkey, antelope's cat, zoo in Hungary, copy some goals. Okay, great. I like all of these mnemonics, so thank you everyone. I think my favorite one will be this one. I think this one probably makes the most sense. So please stop calling me a careless zebra. Instead, try learning how copper saves gold. Okay, good. Right, so no one's given me the half equation for chlorine. So I'll just give people a chance to try and write that. Good, okay, so we've had one answer then. So chlorine ions are Cl minus, so they need to lose an electron to form Cl2, but because they form Cl2, that means we need 2 chloride ions and 2 electrons. Excellent, so remember you can write that the other way as well, so you could write it like so. Good. Okay, so the last kind of couple of questions then relates to what's left. So remember that we had this sodium chloride and we dissolved it in water. And in the water, we've got hydrogen ions and hydroxide ions. So if we just think about the ions that we had, so we had sodium, hydrogen, hydroxide, and chlorine. The hydrogen is produced at the cathode. The chlorine is produced at the anode. So what's left in the solution? What's left? Sodium and this, what does that produce when it's left? Good, sodium hydroxide. So what's left in the solution is sodium hydroxide. And one of the key exam questions we often get is what's left in the solution? So the answer is sodium hydroxide. And the reason for that is that sodium ions are left and hydroxide ions are left. They react together to produce sodium hydroxide, NaOH. And then the other thing they might ask you is how can we test what is left in solution? So what tests could we do then? What is sodium hydroxide? What is sodium hydroxide? Just had another mnemonic come through. Penelope saves lions, cats, measles, and cheetahs. Zara is hungry. Carl smiles gleefully. I like that one too. Yeah, it's alkaline. Sodium hydroxide is alkaline. So how can we test for an alkaline solution? How can we test? Good, we can use pH paper. Yep, universal indicator. Great. So essentially, it's about testing for whether it's an alkaline solution or whether it's acidic. And we're hoping that it shows an alkaline color. So we're looking for the alkaline colors, either using universal indicator, litmus paper, or pH paper. Great, well done everyone. So the final thing I want to do on this slide is just help you guys to remember how we know which products are formed when we do electrolysis of aqueous solutions. So someone asked me earlier, how do we know when we form oxygen at the anode or when we form the halide? So the general rule is that if you have a concentrated solution, which they will either tell you, and if they don't tell you, you can assume it's concentrated. If it's concentrated, you will form the halide, which means iodine, bromine, chlorine, so the halogens, group 7. If it's not concentrated and it's dilute, or if it's not chloride or iodide or bromide, so it's not a halogen ion that's in that solution, then we form oxygen. So if, for example, it's sulfate, SO4 2-, if it's nitrate, NO3 2-, any of these ions, we form oxygen. So the rule that we used last week was, unless you have a concentrated halogen in there, you will form oxygen. So if you don't have a concentrated halogen, you form oxygen. If you do have a concentrated halogen, you form the halogen. That's the general rule. And at the cathode, if it's more reactive than hydrogen, you produce hydrogen. If it's less reactive than hydrogen, you produce the metal. So they're the two general rules with aqueous solutions. Okay, well done everyone. So we've done the half equations for the electrolysis of brine. So we did hydrogen and chlorine. The full electrolysis equation here, but what I mean by this is what actually happens. So it's essentially a breakdown. So we say sodium chloride breaks down to produce hydrogen, chlorine, and sodium hydroxide. And then we just need to balance that. So we know we've produced 2 chlorines and 2 hydrogens. And remember, it's sodium chloride aqueous. So essentially when you wouldn't be asked to balance it because of the fact that the equation is just a breakdown equation. So although you might think you need to balance it, this is just like a word equation. You can write it as, or just kind of the products. So this is just to help you to remember that it's sodium chloride aqueous, produces hydrogen, chlorine, and sodium hydroxide. Okay. Someone's given me another mnemonic. Please send Charlie's monkeys and zebras in lead cages securely guarded. Yeah, great. Thank you everyone for sending your mnemonics. Hopefully that helps the person that was asking for a mnemonic. People suck because most are crazy zebras. Touch little happy children, silver, gold, platinum. Someone's asking, how do you derive a half equation from a full equation? So that was in the old GCSE syllabus. I don't believe it's there anymore. And essentially, it's not about how you derive it. It's about just working out which ions are there. So you wouldn't really be given a full equation. That's a different topic. With electrolysis, you would be asked to write the half equations based on the products. It's not relevant to this topic today. Is a half equation half of the full equation? Kind of, not really. Okay, so let's just go back over the learning objectives from last week and today and make sure we've covered them all, and then we'll do some exam questions. So know what occurs during electrolysis. So that was about labeling all the equipment. So remember, we've got the cathode, the anode, the electrolyte, which is your ionic compound, either dissolved in some kind of solution or molten. And then we have our electricity, so either a battery or cell providing that electricity. Understand and explain the difference between the products produced at each electrode in molten versus aqueous electrolytes. Again, we've been over that today. So our example of molten was aluminium oxide. Our example of aqueous was brine. So in molten electrolysis, we produce essentially what is in the compound that we're doing electrolysis on. Your metal ions will go to the cathode and your non-metal will go to the anode. In aqueous electrolytes, you can either produce hydrogen or the metal at the cathode. And again, it depends on the reactivity series and whether it's above hydrogen or below. And at the anode, you will either produce oxygen from the hydroxide ions, which are what the compound is dissolved in, or you produce the non-metal. And again, it depends if it's a concentrated halogen. If it's not a concentrated halogen, then we will produce oxygen. Is this a year 11 topic? As I'm in year 10 higher and haven't done it yet. Yes, it is a year 11 topic. and be able to write half equations for what occurs at each electrode. So we've covered that in quite a lot of detail today. We wrote half equations on pretty much all of the reactions that we did. So hopefully that makes a lot more sense. But the general gist is that at the cathode, we gain electrons, so reduction takes place. So at the cathode, gain electrons, so it's reduction. And then at the anode, we lose electrons. Oh. And so that is oxidation. Good. Okay, so someone's saying they did this in year 10 at the start. So I guess it depends on how your school go through the curriculum. When I did this, I did it in year 11. So again, it's just dependent on how your school goes through the curriculum. Okay, and then the learning objectives from today were to know the extraction and electrolysis of aluminium oxide, which we've looked at. So the important things there are that it's dissolved, the aluminium oxide from the ore is dissolved in, in cryolite, so that it reduces the energy required to make it molten. And then we produce aluminium at the cathode and oxygen at the anode. And the final point we need to know is that the oxygen will react with the carbon electrodes to produce carbon dioxide. I do personally offer private tuition. I've been tutoring for about nearly 3 years now. Basically since I've been at university, so nearly 4 then. So know the process of the electrolysis of brine. So again, brine is concentrated sodium chloride. We produce hydrogen at the cathode and chlorine at the anode, and what's left in solution is sodium hydroxide. And so if no one's got any questions, we'll move on to exam questions for the last 15 minutes. But as usual, if you have got any questions as we're going along, just pop them into the Q&A. But I want to focus on exam questions because this is our last kind of lesson on electrolysis. Okay, so not quite to do with electrolysis, but good question anyway. Why is hydrogen chloride a gas at room temperature? Why is hydrogen chloride a gas at room temperature? So is it because hydrogen chloride has a low boiling point? Is it because it has a high melting point? We need to tick 2. It's made up of simple molecules. It does not conduct electricity, and it is a giant structure. So what are the answers to that question? Good. Low boiling point. Excellent. That's the first point. So remember, boiling occurs from liquid to gas. So it's definitely a boiling point. That's one of them. And what about the second one? Good. It's made up of simple molecules. Excellent. So the reason that they're important is because if it's a low boiling point, it's likely to be a gas at room temperature. And the other thing that's important is simple molecules essentially refers to covalent bonding. And you'll remember that hydrogen chloride has strong bonds between the hydrogen and chloride, but as a gas, when we boil it, it's not those strong covalent bonds that are broken, it's these bonds here. And these bonds between the molecules are known as intermolecular forces. And it's those intermolecular forces that are overcome when we boil hydrogen chloride gas. And so that's why it has a low temperature, because these intermolecular forces are very weak. Good. Okay, so aluminium is produced by electrolysis. Okay, sorry, before we go into this, someone's asking me, do you have any free slots? It depends which subject you want tutoring on. I do have free slots at the moment, yes. You can find me on the MyTutor website. I can't give you a link for it, but you can find me on there. Are all the lessons you teach taught like in year 11? I try and teach them as I was taught them. Okay, so aluminium is produced by electrolysis of a molten mixture of aluminium oxide and cryolite, which we've covered. And so here's kind of a figure of what's going on. Name a gas produced at the positive electrode. And the key wording here is a gas, which means that there are 2 options. And we know that there are 2 options. So which gas is produced at the positive electrode? There are 2 options here. So aluminium oxide, remember it's molten. Which gas is produced? There's 2 gases produced, but you can give either or. Good. Oxygen. What's the second gas? If it's not, what's the other gas produced at the electrode and why? So oxygen is the traditional answer. Good. Hydroxide isn't a gas. Hydroxide's an ion. It's not hydrogen. Remember, why do we need to keep replacing the electrodes? Good. Yep. Why do we need to keep replacing those electrodes? Carbon dioxide. Yep, so the other gas that you could produce at the electrode is carbon dioxide. So you can either give oxygen or carbon dioxide. I would write it out when you give your answer. All the answers about bromine, hydrogen, no, because remember, when we do molten electrolysis, the only thing that's there is the aluminium oxide. So the only thing that can be produced is either aluminium and oxygen, but the reason carbon dioxide is produced is because the oxygen reacts with the carbon electrodes to produce carbon dioxide. Good, okay. Aluminium ions move to the negative electrode. Explain why. So why do aluminium ions move to the negative electrode? So a couple of things that we need to say here. Someone's asking, why is oxygen produced? Oxygen is produced because when we do electrolysis of aluminium oxide, it's molten. So the non-metal ion is oxygen. So remember, when we do molten electrolysis, we essentially produce whatever's in that compound. So aluminium will be produced at the cathode and oxygen at the anode. It's not aqueous, that's why oxygen is produced. Okay, so why does aluminium go to the negative electrode? Good, okay. So people are saying aluminium forms, the ions are positive and positive ions are attracted to negative electrodes. Yep, I like that answer. So I would say something like aluminium forms positive ions or cations with a 3+ charge. These ions are attracted to the negative electrode, which is the cathode, where they gain electrons to become neutral. Okay. So something like that. Good, okay. At the negative electrode, the aluminium ions gain electrons to produce aluminium. Which type of reaction is this? Combustion, oxidation, or reduction? Anyone remember? So oxidation is loss, reduction is gain. So we've got gain occurring, so it's reduction. Well done. Good, okay. So we'll move on to the next question. Oh. So it was reduction. Okay. Yep, combustion is irrelevant, well done. So potassium chloride contains potassium and chloride ions. The student found that solid potassium chloride does not conduct electricity. Use the correct answer from the box to complete this sentence. Solid potassium chloride does not conduct electricity because the ions what? Good, they cannot move. Remember that when we want to do electrolysis, the ions have to be able to move. And in the solid, they're in that giant ionic lattice, so they cannot move. They're stuck in there. So the correct answer is cannot move. Well done. What could the student do to the potassium chloride to make it conduct electricity? Yep, excellent. So we can either melt it, make it molten, or we can dissolve it in solution. Excellent. During electrolysis, why do potassium ions move to the negative electrode? So just like the aluminium then, they only want one mark here. So yeah, you can just say the positive ions are attracted to the negative electrode. So it's just like the aluminium question we did, but you don't need to give so much detail. So you can just say the positive potassium ions are attracted to the negative electrode. Good, okay. Draw a ring around the correct answer. When the potassium ions reach the negative electrode, they turn into potassium what? Good, yes, atoms. They turn into potassium atoms. They're not going to turn into electrodes because that would just be odd. The electrodes are usually carbon electrodes. So they go to the electrodes to produce potassium. Molecules are what are produced between non-metals. So they're not going to produce molecules because it's a metal. So the only answer then is an atom. And that's essentially what's occurring because it becomes neutral. So well done, everyone that said atoms. Yep, the electrodes can be graphite. So remember, graphite is a carbon compound. So same thing pretty much. Okay, so electrolysis is used to extract magnesium metal from magnesium chloride. What must be done to solid magnesium chloride to allow it to conduct electricity? For anyone wondering, these are a mix of exam questions. So I've taken them from the 3 main exam boards, so OCR, AQA and EdXL. Yep, make it molten or dissolve it in solution. So very similar to the question we just did. Again, a very similar question. So hopefully you can see there are a lot of the exam questions are really, really similar. So why do magnesium ions move to the negative electrode? Again, it's the exact same answer. Magnesium forms positive ions, the Mg2 plus ions, which are attracted to the negative electrode. That's all they're looking for. Okay, what product is formed at the positive electrode then? It's molten, we can see that. Which product will be performed at the positive electrode? Good, yep, chlorine. Excellent, so that's because it's molten. And even if, to be honest, if it was aqueous, we would probably produce chlorine because it's very unlikely to do that in dilute. So it wouldn't more likely to produce chlorine anyway. But it's really important that when you look at these exam questions, you determine whether it is molten or aqueous because that's going to change your answer. So yeah, chlorine is produced. Okay, so Anita investigates the electrolysis of concentrated sodium chloride solution. So brine, it's like what we covered today. What is the name of gas X? So have a look at which electrode it's referring to and then think about which gas it is that's being produced. So it's brine. Remember, it's aqueous solution. Yes, good. Someone's just sent me the answer in capital letters. You are correct. Well done. It's not oxygen, sorry, it's hydrogen. Yes, well done. And the reason it's hydrogen is because it's the negative electrode. The negative electrode is the cathode. And they've actually tried to help you by saying that chlorine is produced at the positive electrode. So we know we're thinking about the cathode. And in aqueous sodium chloride, we produce hydrogen. And that's because sodium is more reactive than hydrogen. So we produce hydrogen. At the anode, we produce chlorine. Okay. It is important to use inert electrodes in the electrolysis of sodium chloride solution. Explain why. Why do the electrodes need to be inert? I didn't take computer science, no. Good. So someone's asked me what does inert mean, which is a really good question. Inert means unreactive. I would recommend learning that word because they like to use it at chemistry. So inert, it just means unreactive. So not reactive, unreactive, inert. Good, and the reason that we want our electrodes to be unreactive is so that the electrode does not react with the solution or the electrolyte. So remember, the electrolyte in this question is sodium chloride. The electrolyte just means the ionic compound that's having electrolysis done to it. So we don't want that electrolyte to react with the electrodes. Is it possible to take subjects that you didn't take at GCSE at A level? I believe it is. It just depends which subjects that you want to take. So for example, you can take economics at A level if you didn't take business studies at GCSE. Yeah, someone's just sent me that as I was saying it. Yeah, really good. Okay. All right, so we'll do this as our last question then. So during the electrolysis of sodium chloride solution, the chloride ions are turned into chlorine. Complete the equation for this reaction. So they've been nice to you, they've actually written it out, you just need to balance it. So how do we balance that then? I took 4 subjects at A level. I took biology, chemistry, maths, and Latin. Good, yep, we just need 2s in front. So we need 2 chloride ions. Each chloride ion loses 1 electron, so that means we need 2 electrons as well. Is this reaction oxidation or reduction? And explain how you can tell from the equation. So oxidation or reduction, which one's occurring? Good, oxidation, and the reason we know that is because electrons are lost in the reaction. Good. So remember though that you can write it the other way. They've written it where you've got a loss of electrons, I think, to help you with that last, with the second question, but you can write it as 2Cl minus goes to Cl2 plus 2E minus. And remember that's because at each electrode, if chloride goes to the electrode, what will be released at the electrode is chlorine and 2 electrons because it's losing those electrons. Or you can write it as 2Cl minus 2E minus to show that it's losing 2 electrons to produce chlorine. So whichever way you prefer to write it, you can write it. Good. So the answer to that final question was that it's a it's an oxidation because we've lost electrons. Yes, Latin was my hardest A level. At GCSE, I took 3 sciences, 2 maths, Latin, geography, ICT, business studies, and German, I I think that should be 12. When does the GCSE course end? So when I did it, it ended in March, but again, it depends on how quickly your school goes with going through all the kind of subjects. And sometimes what happens is that some subjects will finish earlier than others. So I remember my math syllabus and it finished really quickly, but then one of my science, I think it was physics, took ages to finish. And it just depends on how quickly your teachers get on with the subjects. You can take up to 5, I believe, but some people do external A levels. So I think there's kind of a limited number of A levels that you can do. Sorry, unlimited number. Someone's asking, I want to take chemistry and biology. Should I do maths alongside that or Spanish? The answer I always give when choosing your A levels is to choose the subject that you enjoy the most, because you are much more likely to get a better grade if you choose a subject that you enjoy most. Is business good? I enjoyed it at GCSE, but I'm not much of a business person, so I didn't want to take it at A level. Due to the current situations, do you still have to submit courses online if you're uni or college? Yeah, I've just finished my course for this year, but yes, it was all online at the moment. Okay, great. So I think that's it for today. I will see you all tomorrow. And we're moving on to a different topic tomorrow. We're moving on to purity and mixtures. So we've done separating mixtures before, but we're looking more at purity. So kind of tests for gases. We're also going to have a recap on chromatography, because that comes under this topic as well. And I know we didn't cover it in too much detail last time. Is EPQ another A level? Yes, it does count as another AS level. So I know they don't do AS anymore, but it's half A level. Good. Okay. Thank you everyone for today. I will see you all tomorrow. Take care. Bye.